Okay, hello and welcome. We are looking at Lesson 8 in Module 3. Module 3 is all about quadratic equations and functions, and today we are going to be looking at graphing quadratic equations from the vertex form, which is that right there, y equals a times x minus h squared plus k. You should have the notes provided by your teacher, the student edition of the notes, and you can fill these in as we go through. So let's get started. Okay, for the opening exercise here, we are asked to graph these three equations on the interval from -3 to 3 on the x-axis. So I'm going to pull up my graphing calculator here and show these graphs to you. So x squared, x minus 2 squared, and x plus 2 squared. Okay, so x squared, and then x minus 2 squared, and then x plus 2 squared. Make sure you use parentheses when you're typing things in your calculator, or on like a app like Desmos. Okay, when we graph here, there's x squared, there's x minus 2 squared, there's x plus 2 squared. And what do you see happened here? It might be kind of hard to see. Maybe if we turn off one of these graphs. You can turn off the graph by highlighting the equal sign and hitting enter. That'll toggle the graph off, and so we'll just look at the first two. There's x squared, and there's x minus 2 squared. What happened? Well, it looks like it shifted to the right. And how much? Well, about 2 units. And sure enough, if you look at our graph there, x minus 2. It's kind of counterintuitive though, right? You wouldn't expect, you would think a minus 2 would shift it left 2. But to shift things left 2, well, let's take a look here at graphing x squared and x plus 2. There's x squared. There's x plus 2. That shifted things left 2. So it seems like that number there inside with the x, if you subtract a positive number, that makes it move to the right. If you add a positive number, that makes it move to the left that much. Okay? And so let's take a look then back here at our notes. So we did graph it, right? Okay, so what does this effect do? This number in here, right, it shifts things right slash left, okay, depending on the value of h. Okay, so if we have x minus a number, then we expect to shift right that much. If we have x plus a number, then we'd expect to shift left that much. Okay? Now, this h and k also identify the vertex of our quadratic. So the vertex is that, remember the vertex is this point right here. It's either the lowest point or the highest point of our vertex, of our quadratic equation. Okay, so let's go ahead and take a look at these two examples here. So for example, right here, we can see that the h, right there is the 5, and the k is 3. So the vertex, we know, is located at exactly 5, 3. Again, the minus 5, don't get thrown off by that minus 5 and think we need to have a negative in there, okay, because the minus h is supposed to be part of it, okay? H and k is the vertex, the coordinates for the vertex, okay? If we look right here at this next one, right, there's no number h in with the x, so what number can we put there? Well, we could just put an x minus 0, minus 2.5 like that, in which case the vertex is 0, comma, negative 2.5. Because again, that k is negative 2.5. Okay, so the k value, you keep that number, all right, and then the h value, it's the opposite of what you'd expect. Okay, last one here, we have a plus 4, so again, we'll do the opposite of what we expect there. So the h here is actually a negative 4, and the k, there is no number, so k is 0. So the vertex is at negative 4, comma, 0. Okay, and we'll get to the next video here to talk about writing the quadratic equation given certain vertexes.